See, the major things today we are going to discuss about it. Like, yeah, the chat is open for everyone. You can, um, you know what actually? The linear regression means simple linear regression and multiple linear regression. We are going to discuss about it. Previously, we have discussed about a life cycle, and that is the means process of life cycle means how the step-by-step representation of code is going on. Like, okay, so today we are going to discuss about linear regression formulas as well as the clarification about a simple linear regression and multiple linear regression. So yeah, chat is open now. You can. Okay. So I know so many people they are asking about simple linear regression. It's okay, no problem. But how it will be working and what, right? So implementation is good. Already we have seen some practical things, but now also we are going to do that. And simple linear regression means linear regression institution means mathematical background that we have that now we are going to discuss about it. So many questions will rise, but let's check out how this background process is happened, right? Yeah, can I start? If you guys are there. This file will be available for us. Should we take notes? Yeah, you can take notes or I will share. Yes, don't worry. Yes. Now, see. So, what is a linear regression? So, we know that a simple linear regression that we have a statistical method. Okay. So, it's a relationship between the two continuous variables. So, whenever you want to go for the um, continuous data prediction, that time we uh, we can use the linear regression model, right? So think about it. The way I am just passing here the linear regression model, you know that there we have the simple linear regression. Yes, sir, I will share, no problem. Can I get the PPT so that I can follow you with? Yes, yes, no problem. You can get it. No problem. From now onwards, every algorithm you will get PPT. No issues. Because the this process is important for all because every algorithm is important now. So let's go for this one. So linear regression model. Okay. So what is the major thing related with the linear regression? Already we have discussed the continuous variables we have to use, right? The definition linear regression is a supervised machine learning model in which model finds the best fit linear line between independent and dependent. In who is the independent variable? Your features. Who is the dependent variable? Your prediction value, right? So you have to check the relationship between two values and you're going to do a prediction. So if you think about a simple linear regression, you know that single independent variable and single dependent variable means only one dependent variable and only one independent variable. So when I go for the linear regression model, just check out this screen here, right? The left side of the height, suppose I'm just thinking about height and in the y-axis you have the body weight. Is it correct? See, So many people, they are thinking about what is going on here. So because I am just plotting a data here in front of you. See, the body weight and height. So you are going to predict a body weight. See what I'm saying? You have to put a height because x-axis. Check out the x-axis here. Okay, check out the x-axis here. X-axis, and on the basis of height, you are going to predict the body weight. Okay. So what is the formula? Actual formula. There we have the y is equals to a plus b x. Who is the x? X is your independent variable, and who is the y? Your body weight. Are you getting my point here? So still I haven't gone through the whole process. Just I'm just explaining you the formula, the behind the scene, what is going on, right? So check out y is equals to a plus b x. X is your independent variable, means height, and y is nothing but dependent variable, right? Thank you, Rahul. So here, what is the major part to be discussed? In a that particular concept, let's see one thing. Y is equals to b0 plus b1 xi plus e. So I will tell you whole process now. Whole process. Check out one thing here. Mm, See, first I will explain this one, and then I will go for that point. Okay, this is simple formula. The formula, the y is nothing but you know that dependent variables means your prediction value, right? Second thing, b0. B0 is nothing but your intercept. Okay, I will tell you what is intercept and why to use that one, all the things. B is nothing but intercept plus b1. B1 is nothing but your slope. Slope, I'll tell you that one also. But just understand who is a b. What is the name of b1? What we actually call that slope, and b0 is nothing but your intercept. And the third one, that is an x. X is in your observations, means your independent variable. You got that point? Y, who is a y is equals to who is a b0 plus b1 into xi. Xi is nothing but your independent variable. So this is your simple linear regression formula. What I'm saying? This is simple linear regression formula. So tell me now, which point we are going to predict now in this formula? We are going to what point we are going to predict? Rahul says yes, x. X is correct, guys. Yeah, we have to predict y. We have to predict y. So just think about it. Y is equals to b naught, sorry, b0 plus b1 into x. So this is a simple linear regression equation. Okay. So just whenever I show you something kind of formulas and content, just write it down into the your notebook. So this is belongs to this one. This is belongs to this one. Short notes you have to maintain there. I know I can give the PDF of this PPT, but major thing is that you should maintain your notes side by side. Okay. Now let's go for this one. Now let's go for this one. So check out what is the simple linear regression model. So you know what? There we have the x-axis. There we have the y-axis. Is it correct? And check out the red line. What is that red line showing you? Red line. That is nothing but your hypothesis. You can say hypothesis. You can say prediction line as well, or you can say best fit line. So maximum people they think about why this line to show me, means why this line we have to show, right? So this is your prediction line. If suppose don't think about the last here's intersect is there, slope is there, and all these things. Just stay with only red line. I will tell you what it is. Now check out. See, here we have the x-axis. See here. Here we have x-axis. Suppose if I'm thinking about, see, if I'm thinking about, there we have the one point that is in 50, isn't it? That here we have the 50, and this 50 actual data, star is nothing but your actual data point, and this is nothing but your prediction line. So same thing like that, I'm just thinking about it now. Okay, so 50 height inches, okay, 50 inches height, you are going to predict what you are going to predict now. What you are going to predict now? Your weight. So 50 inches of height, and your actual data points are saying your weight is in 120 maybe. So you can think about like just assumption, do the assumptions on this one. So 120 pounds weight is there, body weight, right? So on the basis of your height, you are going to predict what? Body weight. So what is the point here? This star is nothing but your actual value, and this prediction line is nothing but your predicted value showing. So your prediction line is saying that what? If you have height 50 inches, your your prediction value is some around 1.2 something, means 102 something. Just imagine like this one. So you can think like this one. But your actual value says that star means 120 something, and this one is best fit line is saying that 102. So just assumption. So same thing I'm just doing here. Just come to the this diagram. Come to the this diagram. Okay. So see here, the x-axis is there. So this x-axis, this data point is actual value is here. The blue colors line, this actual value is here. But your prediction line is saying your output, this prediction output is this one. If suppose if I'm thinking about your house price prediction, the already we have seen this data set. Okay. The house price prediction says this house price, actual price is suppose 10,000. Okay, 10,000, and your prediction line is saying no, this is a 6,000 cost, means 6,000 price. So whatever the difference between actual value and prediction value, that is an error. This is error. So this error we are adding here, plus error. Okay, so this error, we are having two types of error, that is an positive error and negative error. So whatever the value that we are having in above the prediction line, that is an, this is positive error. If suppose that comes to, see here, this data point, suppose if I'm thinking about this x2 data point, the data point is means actual value is showing below. So how much the cost is there? Suppose this cost is saying that actual value is suppose 3,000, and your prediction line is saying 6,000. Then actual minus prediction value, that around suppose 3,000 minus 6,000. Just think about it now. So what I'm trying to say that your red line is nothing but your prediction line. Are you getting my point, everyone? Your red line is nothing but your prediction line, and you are going to plot first actual values plot, means whatever the actual value is there. Yeah, we have to calculate if suppose in that case plus positive error minus negative, yes, that it is. Yeah, so maximum time we see that data points are means randomly putting into the all over the data set. If you put that into this matplotlib or suppose any kind of plotting area, that time definitely you will get that data points are where it is. Already we have seen into Seaborn that when you pass your data, then it will be showing the proper manner. You have to use their scatter plot so that you can get it easily. But when I'm thinking about a simple linear regression, you have the formula. On the basis of formula, you will get easily, right? So now I'm just think you guys are thinking about, it's okay that there we have the hypothesis line. Is there any term as a mean squared error? Yes, sir. Obviously, definitely you will get that. Yes. So now you got that, means there is a formula that is in y is equals to b0 plus b1. into x plus e. So just don't think about e now. Your whole formula is that b0 plus b1 into x. X is in your observational values, means independent variable, and y is nothing but dependent variable, and those two points. Yes, you got the point. Now I'm just explaining you intersect and slope, but where it is and how it is looking like, that I'm going to show you. Yeah, you got the point. You got the diagram of x-axis, y-axis, and this prediction line, and errors, means positive error and negative error. Yes or no? Yeah. 50%. Yeah, actually, I shown you 50% only. Still, we are going forward. We have to go forward. Okay. Now let's go for this one. So overlap is going on here. Something. Hmm. Now, what is the intercept and what is a slope? So you know that there we have the intercept here in the diagram. You will see that your hypothesis line, your prediction line, that comes into the intersecting the y-axis. So whatever the data in between the that gap, that is intersecting the y-axis, that is an intercept, and slope is showing like this one. See, slope is showing like this one. So calculating the slope, see what I'm saying? Calculating the slope, it's not necessary that always we get in some kind of value on the basis of your prediction line. Means it's not necessary that your your actual values, means actual prediction values, are already means maximum time will get an error. It's not like that. Some data points are on on the line as well. See here, some data points we see in the on the line as well. So some kind of little bit error we get it, means 0.2 0.3%. But maximum time, if suppose if I'm getting this kind of error, then what will happen, right? So now see this one. This is an error, and this is an your intercept, because your hypothesis line intercepting to the y-axis, and this is an slope. So we have to calculate this slope and this intercept. So how can we calculate, and how can we calculate the slope as well? So that we are going to discuss. But major point is that x-axis, and here is this y-axis. So let's go for that, and first explain the point. See now. So this is your now we are discussing about B0 and B1. So B0 is nothing but intersect, because there we have the intercepting the y-axis, and we mostly call that biasing. Biasing means model goes biasing, kind of concept that we have seen previously as well. You know that model goes biasing concept and all, means how the model goes biasing. So I will tell you that when biasing concept maximum affected on the uh, categorical data. Whenever we are going to predict no categorical data, that time many times actually by data model going to bias kind of concept we get it. Okay, so don't worry about it. Is there any way to reduce the linear range? Yeah, actually we have to check for the linear reduce the linear error. So means there we have the reducing concepts as well. But it depends upon, if suppose if I'm thinking about reducing concept, reducing the errors and all, we can get it only what on the basis of your actual data, no? So we cannot go for the changes on the basis of, means we are not going through the changes in actual data, means we cannot change the observational values. We can reduce. So reducing concept means you are changing the observational values as well. So maximum we just understand your observationals, means original data plotting, and that's it. That's the major thing. Okay, can we really reduce it, because we can no control over the algorithm? Yeah, that's the thing that I'm thinking about. If suppose if I'm trying to reduce that, we are going to change the observational values as well, means your original data as well. So better to change, we can just plot it down and we can get it what actually it is. So the way I'm just showing you diagram, just think about it. The prediction line says that your data should be on the red line only. So how it is possible that your changes means on the basis of your actual data you can get it accurate prediction? Is that correct what I'm saying? Because you cannot change your original data set, no? That's it. Means you can think about that. Okay, that is an actual value and this is an prediction value. So many differences we are getting in between that. If suppose that is getting into upper side, then that is a positive difference we are getting. So we should have to think about that. We can reduce, means not by mathematically. We can think about, means orally, means we are getting that much huge. So we should go for that one. Okay. So I think many of the people's, if suppose think about linear regression, no, they confuse about plotting, about output as well. Why they are confusing? Because you are not getting any such kind of data that is an categorical kind of concept. Means the way we are thinking about logistic regression or KNN, there we have the multi-classification classification concept, means binary classification concept. So your output is, that your output will come under the 0, 1 or some decided patterns only. But in linear regression, you cannot get it easily. So that many people they get confused in between that. Okay. So let's just move for the one thing here. Sorry. So B1 is called what? Slope. And slope, that line, see how the X translate into the Y. So X translate into the Y means what? You are you are making the plots, you are making the hypothesis between the X-axis and Y-axis, no? So that is relate with the corners. Just check out the before as well. See here, if suppose if I'm thinking about, this is your actual data points, no, this is a plottings, means this is a hypothesis your, right? And this is your slope. So how much slope that we got it here? So we have to calculate that slope as well. I have the formula of slope, I have the formula of intersect as well in this one. So but just we think about it, how the each process will go for that. See here, what is the B1 here we have? Do you know about it? What is the B1? Slope, no? Is it correct? So formula is kind of huge, means sum of xi minus mean x and into y minus mean y, means this is the bundle of formula, big formula. So if you are passing in between that, then definitely you will get it easily. So the reduced concept, and I'm just making some simple things here. So just go for this one. See, estimated the slope. So estimating a slope is nothing but 1 divided by n into sum of x. So this is kind of simple mean, isn't it? Isn't it? This is kind of simple mean. Yeah. So if suppose, if I'm just taking some examples here. If suppose if I'm thinking about a mean x is equals to 3 and mean y is equals to 2.8. This is a simple mean of that plot. Okay, calculating this one. So question that, for example, there is any minimum value and maximum value in the algorithm. Minimum and 100 records are needed to teach, and after 1000 records, line a finite slope. Hundreds records are needed to teach, and after 10,000 records, the line is finite slope. Actually, it depends upon how much observations you are getting, means how having. If suppose you are trying to hundreds of records to the teaching, and you can pass it down, yeah, it's just range. Yes, yes, yes. I got your point. So, see, at the end of the point that we are finding only whatever the data we have. See what I'm thinking here. You guys are thinking about, if suppose if I'm thinking about Suppose my data is there, right? You don't know that uh, my data is correct or not, but you have the actual observations, and you are trying to train your model that whatever the data I have, you just train it, means you just learn it yourself, right? But what we are thinking, if model is learned properly, our data, because already we have the observational values. See what I'm saying? Already we have the observational values. Model, we have to train our model. We have to means model should learn all the data. Okay. And after that, means after the training, after the model learning, what we are going to try, I'm sharing some amount of data to the model. See what I'm saying? I'm sharing some amount of observational values to the model, and trying to find out my model is giving correct output or not. So that's why if I'm thinking about, see, that's why if I'm thinking about here, already your model is trained, okay? And you are taking your observationals, means whatever the training data you have, in that you are taking some of the trained data and putting down into the your prediction line. And then you are checking whatever the model is trained, whatever the model learned something, isn't it he's going proper way or not? So that time your data is looks like this one, some part of data you looks like one this type, but some data he learns, but he giving the some sort of errors here. So this is a positive error and this is a negative error you are getting. But without training model, how can model can gives the output? There we have the formulas and all, not any easy, not an issue about that one. But without training you cannot give the output, cannot think about output, and you cannot blame on your means your linear regression algorithm as well. Now just think about it, estimated slope that we can get it, means slope, if suppose I'm thinking about x-axis slope, e1 is an error. Yeah, yeah, you are, means the way I said, no, the positive error and negative error, that's the same thing. So 1 divided by n into the sum of x. So the way we calculated the slope, so there we have the mean x is equals to 3, that is in slope, okay, slope, and mean y is equals to 2.8. So just think about one more step. Estimated the intercept, means this is your intercept and this is your slope. So we want these values b0 and b1. So the way we are having the b0, just think about it, b0 is our intercept. So mean y minus b1 into mean x. So can you tell me what is the mean y here we have? 2.8. What is the b1? I think I have never calculated the b1. Actually b1 we have to calculate from this one. I never get it. But what is the b1? That is in 0.8, and into 3, mean x is nothing but 3. So 2.8 minus 0.8 into 3, that is in how much? So you can get it from this one. So zero point 0.4 we are getting. So b0 is in zero point 0.4. Okay, b0 is in zero point 0.4, and this is you are estimating the b1, and this is my mean. So x-axis mean is 3, y-axis mean is 2.8, and your b1 I never calculated of calculate this value actually. B1 means calculating the slope, but I got in that value here. See the b1 0.8. So I'm just taking the some examples to understand yours, right? You got the point, some values. Don't worry about formula and some values. I'm just taking the random values to understand yourself. That's why. Okay. So B1 is nothing but what? This is a formula B1, sum of xi minus mean x into yi minus mean y divided by sum of xi minus mean x square 2, root 2. Okay. So check out. B0 is equals to mean y minus B1 into mean x. Now just think about it. What is a n? Where is an n? N is nothing but count. Where I have you have seen that N? I'm lost. What? Previous slide. Okay, wait. See, once again I'm telling you, this is in mathematical terms. Okay. So at the end, what we need some values on the particular variable. So whatever the variables that I have given in on the screen, that values I am sharing you. Okay. So this one. This is your B1. Who is a B1 here? Slope. Okay. So you will get these values easily. Means mean of x, xy, xi is nothing but who is that xi? Can you tell me who is a xi? Who is xi? Yeah, observation values means your x values, independent variables. Exactly. And second thing, see here, there we have the y values means y value is nothing but dependent variable. So check out if you want to calculate the b1 means your slope, you have to do this process. So once you pass this process, once you do this process, then you will get a slope of your theta. Okay. So after slope, I have to calculate mean of x and mean of y, mean of independent variable, mean of dependent variable. Okay. Then you have to go for b0. So who is a b0 here? Your intercept. If you want to calculate the intercept, you need a mean y and mean x and b1. Calculating the intercept, you need mean y means dependent variable, mean x means independent variable, and b1 is nothing but your slope. Now got the point, everyone? Now, so if I'm going to add b0 is equals to b0 is nothing but what? Intercept is equals to 2.8 is nothing but mean y minus 0.8 is nothing but who? Your slope into 3. So 0.8 calculation I don't have, but directly values I have that 0.8. And then once I b0 got that, the final output is that b0 is nothing but zero point 0.4. So now we have what are the values we have here? If suppose if I'm thinking about b1, we have zero point 0.8, we have b0, that is nothing but 0.4, and third we need observational values. Who is that? X value. On the basis of that, you are going to calculate the y value, means prediction value. If b1 is equals to 0, then what is b0? Then I have to calculate, sir. If suppose b1 is your slope, no, so you have to put that 0 into this formula. So b0 into 3, that 0, and 2 whatever the y value is there, no, so 0.8 minus 0, that is in some kind of 0, 2.8 you will get. Is it correct, sir? I don't know, means I'm not going deeper here, but if you think about b1 is equals to 0, okay, so you know what actually, how can you get that 0? But isn't it? Are you getting my point? How can you get it that 0 directly? Because when you think about b1 here, the way we are calculating the b1 here, see, calculating the x-axis, calculating the y-axis mean, definitely you will get in some kind of positive value here, right? So now I think let's check out a making of predictions. Making of predictions, you know what is the formula there we have? What is the formula? Check out the right side of the screen, simple linear regression equation there we have. y is equals to b0 plus b1 into x. So can you think about it? What is my b0 there? 0.4. What is my b1 is there? 0.8 into x. Who is a x? Who is the x value? Can you tell me? If suppose that is an independent variable, isn't correct? That x is nothing but your independent variable. So whatever the value you are taking now, you have to pass. Suppose your independent variable, the way I'm just thinking about your body weight means predicting the body weight on the basis of your height. No, so height is there 50 inches is there. So you have to calculate height 50 inches means predicting the body weight. So that time 0.4 plus 0.8 into 50 inches means 50. Okay. So whatever the value calculation will come, no, that is in y means prediction body weight. Prediction of body weight. Are you getting my point? So yeah, that's the thing. That's the thing. So many people are thinking about your machine learning is very tough. No, machine learning is not tough. Trainer is good. If suppose your training trainer is good, no, then definitely your machine learning will go into best way. But if your trainer is in bad, no, means trainer get confused, then your all the things will get confused. No, no, no. I'm just, what, actually you have to learn with the best flow. The maximum time many people they say that you have to learn about some mathematical things means first some stats things, and they are getting confused about it. So first they confuse and then they enter into the machine learning because many people uh, they thought like ML is in toughest thing. No, not in toughest thing. Predefined some algorithms are there. If you know the way of finding the answers, no, you are best in this domain. So let's go for this one. So see, at the end of the process, if suppose if I'm thinking about simple linear regression, you know that there we have means finding the errors and all, right? Even after the simple linear regression, if I'm going through the multiple linear regression, 101% we get an some query means some point. Are you thinking about if I go for the independent variables means independent variables and multiple independent variables? Just think about it. How many independent variables you will get, isn't it? You will get on multiple independent variables. So you are adding x1, xi, x means x1, x2, x3, x4, that is in values. See, the way I'm working on the simple linear regression, right? The way I'm working on the simple linear regression, you know that the only one value is their changes, that is an x value. So now we are taking single independent variables. But if I'm going for the multiple linear regression, then you will get a multiple independent variables. So you are passing a x1, x2, x3, x4, xy. So you are calculating with the your slope as well as the intercept. So that also we are going to discuss about it. But don't worry, I'm just going forward and tell you. So estimating the errors. So formula is there. See, we are not going deeper here, but I want to tell you that how to estimate the error. So we know that I just previously told you that positive error and negative error. So positive error, just think about it, positive error and negative error, right? So let's go for it. Hmm? Yes, Rahul. So actually that isn't stable. No, your y-axis will not change, isn't it? Your y-axis will not change. But with the multiple value, if suppose if you think about it, then he will change, not an issue. But maximum b0 and b1 will stay same. When? simple linear regression. So that is also we are going to discuss about it. Don't worry. So square root is an square root. You will just think about it. Square root was in your function. You will get it, that function as well. So sum of pi minus yi into, so pi minus yi that divided by n. You know the n is nothing but your count, okay, and yi is nothing but prediction values, and p is nothing but pi means actual value and prediction value. See what I'm saying? Actual value and prediction value. So n is nothing but number of predictions. No, sir. N is nothing but number of predictions means count of number of predictions. How many numbers of predictions are there? That. So always you know that how to calculate the actual value minus prediction value. So y is in your actual value and p is nothing but your prediction value. Isn't it correct or not? Yes or no? You got the point, guys? See, by orally also you can calculate, but many times if suppose you have in thousands of observational values, you will get in problem. So better you can use this kind of concept if you pass it down either square root, sum, and what. Once again I'm telling you, p is nothing but your prediction value, y is nothing but your actual value, and the n is nothing but your what, count of number of predictions, how many number of predictions, right? So yes, yes, ma'am. So difference between actual value and prediction value, that is nothing but your error. Okay. So the way I said you previously, positive error and negative error, how can we say, means the terms that you know. So whenever you think about the prediction below the prediction line, above the prediction line, that isn't different. Okay. So think about it, each and everything. Now let's move some multiple linear regression. Okay. So you know that there we have the formula of, see, y is equals to y0 plus y1 into x1, that is in your simple linear regression. If I'm thinking about multiple linear regression, y is equals to y0. So now just think about it. What is the meaning of y0? Can you tell me? Can we check about once again? Who is a y0 here? Who is a y0? Yes, sir. Thank you so much, sir. Who is a y0? Tell me. B0, sorry. B0. B0 is nothing but intercept, isn't it? B0 is nothing but intercept. So check out one major concept here. If I'm going through this one, B0 is nothing but intercept. Is there anything that you are looking for that B0 is changing here? B0 is changing or not? It is a constant value, no? So plus B1 into x1, B2 into x2. So that who is our B1? B1 is nothing but your slope. So slope changes according to the independent variables. Now got the point? This class is important, guys. Okay, so do not take easily here. This class is important. This first algorithm is important. So you will get that who is the intercept, who is a slope, and who is a that hypothesis line, who is the x-axis, y-axis, and all these things. So the way implementation of simple linear regression works, the multiple linear regression says that if you are thinking about b0, B0 is nothing but intercept. Intercept is in constant, and B1 is nothing but your slope. Slope will changes with the independent variables, means your observational values, because x1 is not a single observation. X1 is not a simple one independent variables. x1 having multiple independent variables. Why? Because we are working on the multiple linear regression. Are you getting my point, guys? Yeah, that's the best thing. So whenever, see, whenever I'm thinking about multiple linear regression, you have to think about okay, means you have to remember that formula. Okay, and keep it mind that, because I'm not showing you a critical and scrambled things in front of you. This is very simple manner you are having in front of you. Means simple linear regression formula is this one, multiple linear regression formula is this one. If I'm thinking about the errors, you can find out with the that error formula. If you want to go for the intercept, you have the formula. Calculating the slope, have the formula. Want to go for simple linear regression, pass the one independent variable. Want to go for the multiple linear regression, pass the multiple independent variables. That's it. This is your major heart of your multiple linear regression, means all regression point. But the whenever I go for the whenever I go for the regression concept, you just keep in mind that definition. What I'm saying, definition says you all, right? You got the point, guys? Got the point? Everything related with the multiple linear regression or simple linear regression. See the point here now. So y is equals to, this is a formula just I mentioned in front of you, that why, because you will get sorry, you will get some easiest work here. um See, the multiple linear regression, actually I have mentioned here some um, definition. And right side you will get, and the b0 is nothing but intercept, b1 is nothing but slope of first independent variable, first dependent, second, third independent, x1 is nothing but first independent. See, now the way someone asked me about the b1 is nothing but slope. Check out the words that I mentioned. b1 is equals to the slope for the first independent variable. See what I said? The slope for first independent variable, slope for second independent variable. Means what? What is the meaning of this one? Means slope changes. Slope changes when independent variable changes. Got the point, guys? Okay. So this formula should be a b1 into 1. Means number of rows records. Uh, Actually, in the array section, you will get an n count, means counting the n. If you think about, your index point will start from the 0, then you have to mention there n minus 1. Your index is starting from the 1, then you have to mention n directly. B1 in x1. Yes, yes, ma'am. Yes, correct. Pooja Sharma. Yeah. The B1 into B1 x1, B1, B2 x2, B3 x3, like that. Is there any multiple lines in this graph? Multiple lines, if it depends upon how many hypotheses, how many graphs you want to. Means if you make a changes in your structure, then definitely you will go. Yeah, I got that. B1 x1. Okay, actually here we have the mistake actually, but this is x1. Yeah, now got the point. Yeah, you are right, Pooja. B1 x1, B2 x2, B3 x3, like this. So let's check out one thing here. So can you tell me? Yeah, you, why I shown you, in the last session, actually, we executed, but executed because of the whole journey. Because life cycle I told you in the in the last session on the basis of your linear regression. Okay, but what will be there? You don't know the background, means what is going on there. So that's why I'm just showing this one here. Now you got the point that you know the background things, means background actors. Who is the background actors here? Intercept, slope. Yes. So now let's go for this one. So if suppose now I'm just thinking about what if suppose if I'm going with the some other algorithms as well. No, now you get to know about what is the major stuff. The first stuff, whenever I go for the other algorithms, that there we have the intercept as well. There we have the intercept, means constant and intercept. Second, that there we have the slope value as well. You got the observational values as well. You got the dependent variable as well. You know the errors, means how do we identify the errors as well. Now maximum, the representation of algorithms, means plottings and all. But now if we go for some sort of working with for practical things, let's go for that. We can check about the practical things as well. So already we have seen in the last session about practical things, but very quickly we can see that one as well, and even multiple linear regression also we can go. Yeah. So today we can get it easily, that multiple linear regression and simple linear regression. And tomorrow, tomorrow I will go for some tutorial on the basis of multiple linear regression, because I don't want to go for the directly into classification. In the next week, we'll go for the classification algorithm, and I, I think in the next week only we'll discuss about many of the topics. Okay. So now, let's go for. Thank you. Okay, PPT is covered. So let's go for this one. I'll just binary classification. So for binary and classification, are those related as well or totally different? No, that isn't same. No, means classification comes under the two types of concept. I think everyone, you guys watching, know that chat box. That is no question is very genuine question. The classification has two types. First one is in binary classification and multi-classification. So both are same. Rahul, you got the point. Uh, Wait, I will show you screen here. Hmm. So now, just I want to ask you, you got the point related with the simple linear regression, how we means how the algorithm works properly on this basis, because that is the major thing. Okay. So simple linear regression purpose now I'm discussing. So simple linear regression, that plotting is important here. See, okay. Then there I have passed a salary data. Okay, salary data, that means how the salary data is working. So I'll show you first the data set and then we'll go for that. Okay. See, so on the basis of year of experience, you are going to find out the salary. Okay. Training, testing, splitting. So I think you know that training, testing, splitting as well, isn't it? Training is nothing but train the model. Testing is nothing but you are testing. Means once you train, you have to test. Okay. Testing, training, testing. And one more thing, I'm just asking to you, is it possible that we can pass the whole data set to the training? So we can pass. Then what is the drawback that when if I teach all the data to the model, what will be the drawback? See, drawback why I said uh, to identify the accuracy. Yes, yes. Identify the means errors. Then you have to slice some data to check. Okay, too much independent variables. Actually, dependent variables means what's the problem there? You will get a problem 101%. You cannot change that one, right? Imbalancing. Yeah, you used the word of imbalancing. We have to divide the small chunk and and yeah, that's correct. Actually, we have to divide because identifying purpose, understanding purpose, how the model is going properly or not, that purpose we have to slice down the some amount of data. The word that you have used in balancing, the imbalancing word, when it comes, when your data is category. Yes, it is, imbalancing, because when this terms comes in balancing, one of the category you have in higher count, then your model is going to bias towards the hiring count, means highest level of category. That time in balancing comes. So model goes into the favor of that higher higher level of category. Yes or no? So training, testing, splitting now, now, and then I'm just thinking about what model. So the behind the scene we have seen that about linear regression works, and whatever the things means within a three lines we cannot get it easily, but the background process that we have seen in the PPT. Okay, so check out now, execute it, and check out here. The ypred is equals to regressor dot predict. So regressor is who is the regressor now? Your algorithm. Dot predict is my method, and you have to pass x test. Who is the x test? Because you have sliced down the data. So how much data we have sliced down? One third. One third is nothing but you can say that is 25%. You can pass it down a 0.2%, 0.3%. But if you want to go for the 1 divided by 3, that is nothing but 25%. So you got the point, guys. How we have sliced down the data and passing into the testing set and training set, and then we trained. So which data we have to train? X test y test or x train y train? Means, is there any compulsory that we have to train only x train y train? Why not we go for the x test y test? Is it correct what I'm saying? The question is very genuine. If suppose if you are getting some interview some questions, and suppose the interviewer type of me, then definitely you will get confused. Max value for the training. Exactly. You can give the maximum value. If suppose if I pass the 20% of data to the model training and 80% of remaining value for the testing purpose, then definitely you will get confused about that, and model gets confused that I learn only small amount of data and you are passing a huge amount of data to the testing purpose. So definitely your model will not give the properly answer. Okay, you will get a difference, means many type of errors there between that. So predicting the test set result, that we have passed the X test, and you know that X test data, if I thinking about this, I can predict, I can pass here Y underscore predict. See, so we got in Y data, and you know that there we have the X data as well. So X data means your actual prediction value, and now your predicted value, now desired value and actual value. What I'm saying, actual value and desired value. So whatever the things that we have now, so that I'm going to divide. If suppose, wait, we'll do little bit comparison and then I will go for the plotting purpose. You will get to know easily. Okay. So y underscore text. Say 37,731, some kind of value, the first, and YPRED is giving you 40,000. Second value is in 1,22,391 salary, and your model is saying 1,23,079. Third one 57. This is third one saying 65 should have to give 63, 63. See, this model is run properly. Why? Because the difference between actual data and predicted data is an very low. Is it correct or not? 37,731 to 40, it's same. Little bit difference we have. 1,22,000 to 1,23,000, same. The little bit difference we have. So you guys are saying that can I believe on my model? You can, no problem. But if you want more, if you want more accuracy, then what? Then you have to work on your observational data. Then you have to come for the prediction. Isn't it correct or not? Are you getting everyone? Today, what is the major point we have discussed? You know what? If you learn this point, near about 6 to 70% machine learning concept you learn now. Why? You know the steps, you know the major background things, you know the that plotting purpose, you know the dividation concept, you know the model creation, you know the size, means on the basis of size you can make the multiple models as well. So check out, if you want to change, if you want to train all the data to the model, definitely your answer should changes. If suppose, if I'm thinking about, suppose I'll pass 0.2, so zero point 0.2 already passed, I'll pass only 0.1. Okay, so 90% data goes into the where, training purpose. So if I execute this one, now check out. How much difference we get? Very rare difference we are getting. So very slow, very low amount of difference we are getting. The previously also we got it that 37 point something, 37,731, and now also 40,000. So the very low count of even to 1,22,000 to 1,23,000. So now the many people think about how can we believe on, yes, there is a not even very rare changes we got it, very low changes we got it. But now the question is that on the basis of that, how can you believe on your model? First thing, you know what? First, you have to change your test sizes. You have to change your random state. Are you getting my point? If you want to check the difference between the output, how many points that you can make it changes. So first, if you want to write it down, no, I'm just telling you, just write it down some points that I'm telling you. How did we means how how many ways to changes you can make the changes between the output. First, you can go for the test size. Second, you can go for the random state. Third, you can change the observational values, means make the x-axis and y-axis is there, no, so x-axis data you can change it means you apply the standard deviation, apply the some normalization concept, and you can make it changes. And fourth, I'm just going to think about it. You just you just pass the whole data set to the model for the training purpose. That's it. These are the changes if you made, no, then definitely you will get some differential point. Then then question will rise, out of that, which model is best? How can I think? See, which model gives you some accurate prediction, like actual prediction, that model is the best. Are you getting? No. If suppose you already trained some 80 doggies to the model, and your 20 doggies you are remaining, means you are making some reserve doggies of 20% testing purpose, then you have to relate with that he is showing the doggies or not, like that, no, you will check that comparison between that, then you will say that. So some and even the many people say, think about, can we believe on the accuracy? See, previously already said that accuracy is a different thing, accuracy is in your secondary thing. Even your model is learned wrong, no, your accuracy will show 100%. So how can you believe on that? You cannot. So difference between actual value and prediction value, which model gives you lower difference, that value is that model is in best always. So keep believing on your that error points. Okay. So now let's go for visualizing the training set result. Will I pass the whole data set into the training, 20% into the testing? Will the prediction changes or gives the same value? Sir, what's the problem that then what is the use of your 20% testing data if you train all the data set? Are you getting? Means why to say that testing purpose? So you are taking that from training data set as well, no? So you can't believe that. You can't believe that. Means even suppose, means the word is like your trust will broken when you train all the data, and if suppose then also your model is not giving proper answer, then you say that my algorithm is very bad. So I think you got the point now. Yes or no? Okay. So now just see the plotting here. The plt dot scatter x train comma y train. So you know that training data set color is equals to red. So don't ask me now about what is the color values, and what is title, x label, y label, and show. So these are the matplotlib that we have seen previously as well. So if you have learned previously, that's that is the point, right? So plt dot plot, you are passing x train comma regressor dot predict x train. So what is that actually? Your y pred, isn't it correct or not? Regressor dot predict x train means you are passing instead of passing x test, you are passing x train, you are storing that x trains data into the y pred. Means what? Way just some of you said that, why if suppose I go for the testing if I pass the extrain only to test. So if you pass extrain and put the output, you will get an answer as like this. Check out. So what is that training set? Who is the training set actually? Extrain, comma, ypred. Extrain, comma, ypred. Ypred is nothing but your prediction value. So what you are passing here, year of experience on the basis of salary you are calculating here. So this is your actual thing. And you guys are thinking about this is regressor is nothing but your algorithm. Yes, that is an algorithm. So whatever the things that you are getting know here, that is your completely uh, prediction values you are getting here. If you want to check, see what I'm saying, if you want to check what is the actual value, then you have to pass their y train, x train comma y train, and check the output. So that is your actual data. And the way I'm passing here, regressor dot predict x train, that is your prediction values. Are you getting my point? What I'm telling to you? Actually, you know what? Um, if if we wait, you know what we have done actually. You know the two lines of we combined. What is the code that we have seen? I just forgot that code. Not clear how to split test and train dataset. Here we have done here. See here, train test split. The x comma y test size is equals to 0.1, means once you pass the 0.1, that is what test size, and 90% is an train size. So this is splitted into the x train x test, y train y test. So x test and y test is getting how much? 10% data. Yes sir, 10%, and 90% goes into the x train and y train. Yeah, yes sir. So you know the combining two plotting into single, what we have done actually. Wait. Oh, oh. Hmm. Wait. I will show you something here. Wait. Tarek sir, just give me a 1 minute. I will just explain you. Yes, I will explain you, and then I will go for that. Okay. See, guys, the PLT dot scatter x train y train comma color is equals to red that we have passed. The color is equals to red, that's showing you actual values. Are you getting my point? The scatter plot means the dots that are the reds are no, that is an actual values. Isn't it correct? Yes or no? And plt dot plot xtrain comma regressor dot predict xtrain comma color is equals to blue. This is nothing but your prediction line, and those are in on the basis of those are touching the prediction line, they are best fit prediction values. See, these are the values are touching. Means what? Means they are giving the accurate answer, means they are clear answers. Yes or no? Now check out. I will discuss about this point. See here, this point, or I will discuss about this point. Okay. The prediction says this is around 4, 5.2 something of your, see, 5.2 something your year of experience, and your output is saying that how much? Your output is saying, sorry, my drawing is bad here, but this line is showing that this much salary we should give the that person, but your actual data is saying that how much he should get, how much he's getting, how much? 8,000, 80,000 something around he's getting the salary, and the prediction line says do not give this much, you should have to give this much. Are you getting my point? Yes or no? And the difference between this one, what happened here? The difference between this one, this is your error, so this is positive error. Okay, so the difference between this one here, we have the negative error. Yeah, yes sir, this is negative error, this is positive error. Actually, this is, we are doing some kind of structural part here, some kind of differentiate the way we have passed what x train. So we, that's why we are getting huge amount of values here. If suppose if I'm passing here y train, no, uh, x test, then what will happen? What happened here? How can I close this one? Okay, see here, I have passed here x test data. So you know that x test data, how much data we have? Only 3. I have to improve the points. Why? Actually, at the 10% I have taken, no, the 30 total data, and 10% of 30, how much? Only 3. Means we have trained 90% of data, and we are getting how much? 10 to testing. So 10 to testing purpose means that data goes into the points. This one, these are the points that we are getting here, and see the difference that we getting here. But with the low count of testing size, we are getting properly, means visibility. Check out the third point, second point, and first point. First point is having 1 year of experience and what. So this is looks very easily implementation. Yes, sir. You have taken a good example. 177 Amitabh Bachchan has a height of 188. So means Amitabh Bachchan having the means he's you know the word of that the word I don't know actually, but now the average height is Indian man is 170 while Amitabh Bachchan height is in 188. So error is positive. Yeah, positive error. But suppose what about other people? If suppose if I'm thinking about um, you cannot say no about that person isn't having this much height. Means I'm just on the basis of observational value I'm saying you can say bias value means um, the model biasing or the value we are getting outsider like that. So Amitabh Bachchan is kind of outsider means up the word is in our side we can use upward something. What is that? Anyone knows the word? Those are having the background of Hindi background. Upward. What is the word? Exception. That's Amitabh Bachchan is exception of that one. So I think I think if suppose if I'm thinking about other points, you know, if I would like to go for the multiple linear regression, no outliers exactly outliers. Now the Amitabh Bachchan is outlier. So can we go for the multiple linear regression? So once we cover up, no, the way we implement, no, about simple linear regression, you got the point of these whole process. Implementation and visualization is secondary thing. Visualization is not part of our journey, but our main journey is in learning the algorithm, background actors. Okay, those are in the background. So importing the libraries that we have here. Okay, so this is data set. See, here we have the 50 startups. What I have said. Here we have the 50 startups. So many things will rise now. The questions will rise here. So check out. What is the major drawback for this? The last model you predicted. Last model predicted drawback. Model drawback or a linear regression drawback you want? Model drawback is nothing but you are passing a 90% means you are training 90% of data and you are trying to predict only few amount of data. So model already know everything. It's kind of concept like that. Okay. You have to give the some amount of 70-30 to 80-20 is enough so that you can get it accuracy properly. If suppose if I'm thinking, so many of the factors will come, many of the observational points are coming, many of the question marks also comes. Why? Because the way I'm just thinking about the credit card fraud detection, credit card frauds are dedicated, means fraud predefined frauds are there, isn't it? So how could someone his company will agree to lower their income? See, actually you are showing only observationals. The believing on that concept means, see, just see the front of you. You have a database here. The profit is now like a 1,92,261. The first row, check out this one. I'm just giving you this example. Okay. So if I want to go for the profit prediction, and I said, suppose your profit should get only 1,50,000. That time you are capable, you are satisfied, no? Because your prediction algorithm is saying that you have to predict only 1 lakh, means you have to get a profit only how much? $1,50,000. But you got an actual profit 1,92,000. That time you will not blame on that model. Why? Because model is saying now you will say that model is now true. But suppose some kind your model is saying you should have to get $2,50,000 profit, but you are getting 1,92,000, and that time what do you say? Your model is bad? No, no, means that time you say that, huh, my company is bad. Why? Are you getting my example? What I'm saying? See, the if if always I want to predict something, you have to believe on your observational values, means independent variables observation. If your independent variables is wrong, now you got the point that how the means how the independent variable is important, means how the data pre-processing data cleaning part is important. If suppose your data pre-processing part is wrong, then definitely that affects on your prediction point, isn't it? Which side of the 10% comes from the head or tail? Actually, head and tail is not your, it's kind of showing the data only. And your slicing of 10% that comes into the training data set here, here, 0.2%. This is this part. This is random state and test size you have to pass. Yes, got the point? Now, I'm just trying to explain this data set. This is a 50 startups data set from the America. Okay, there we have the state kind of New York, California, and Florida. Three states are there. So state column is the only categorical data, and other columns are belongs to continuous data. So the zero numbers means just index based. I'm not giving any kind of name here, the company's name here. Just do the assumptions here. The zero numbers company, that company spend on the R&D how much? 1,65,000 something. Same company spend on the administrator, same company spend on the marketing, means that much money they have spent. And that company is from the New York, and that company gets the profit how much? 1,92,000. Means this is your actual value, and that these are the 50 companies already they have spent R&D, they have spent money on the R&D, administration, marketing spend, and that location as well, means state as well, and they got an profit that much. So we have to train this much data to the model, and whenever I ask to the model, whenever I, whenever I, my company, if I'm taking and passing into the model, sorry, my battery is right. So whenever, if I'm thinking about, my voice is audible to you? Good. See. So whenever I'm thinking about, if I'm taking my company in front of in passing into the model, then model always gives the what? Model always gives the some kind of prediction. So we have to check same concept that previously we have done. Which one? The way previously we have calculated the salary. Here also we have to calculate the profit as well. Only you have to pass what? Multiple independent variables. Process same, structure same, formula changes. Formula changes means what? Which part will change? Which part will change? now you know the formula as well, means now you know the process of concept as well, right? So maybe the point is that you have to change slope and independent variables here. So here we have the some kind of independent variables, the multiple independents where R&D spend is also one kind of independent variable, administration, marketing spend, state also, and it depends upon you that you have to pass state into the algorithm or not. If you want to remove that state column from the algorithm, you can remove, because it's not necessary that you should have to pass like means you have to pass whole data set to the model, you have to train whole data set to the model. It depends upon us. So if administration d type is an object, we change to integer, right? How we do that? Forget, sorry. Label encoding, is it correct? You know that already you have done, guys, label encoding concepts, correct or not? Can we go forward? Can we not do through the as? No, how can you do? How can you convert that one? If you change, is it's not possible with the as type. Why? Because how can he understand that New York is a string and you are saying that that isn't true? Means, it's kind of you are trying to tell dog to your man, isn't it? Rahul, you got the point now. Revise previous stuff. Which point? Means profit column, you got that. Means multiple profit is in continuous data, and R&D, administration, marketing, spend, and state column. State column, you have to convert the column, because see, yeah, the way I have sliced down the data set here, X and Y, you know that minus, till the minus one is nothing but your R&D to state column, and only minus one is nothing but profit column. That's why I have made here the X and Y data. Okay, so this is my X and Y data, and you are going to pass that data to create testing set and training set. Isn't it correct? We have to pass no into the model to create a training and testing set. To go to the training and testing, before that you have to maintain, you have to convert that state column into what? Numeric. Check out. See here, the encoding the categorical values that we have seen one example here. What type of problem we got here? We have to convert that data into the numeric. That's the major thing. If we don't convert state and not pass into the model, will figure be changed it or not? If you not pass, that's it, not an issue, because it will go for the prediction on the basis of only 3 parts instead of going 4 parts. Means it will not considerable column. Yes or no? Now the encoding categorical data, that is an sklearn.compose column transformer. Column transformer is nothing but your class for the converting your observational means after conversion your observational data comes into the separate form, means separate column wise and data. So I will show you how it is. The second thing is in data preprocessing package, that importing the one hot encoder. So one hot encoder
is an binary data encoder. So whenever your interviewer asks, what is the data, means what is the binary encoding concept, means how do you convert your data into binary encoding, binary data. So that is, actually, there we have binary classification. We already know binary classification is nothing but 0 and 1. But suppose your data has an more than one categories. How much more than one? Means suppose I'm having three categories. Just think about it. How can we convert your three categories into binary? So first, if I say one, means first category is if I say one, second is 0, third is 0. Second, if I say one, first one is 0, third one is 0. Third one is in 1, first and second one is 0. Are you getting my point? Actually, I'm trying to give you some examples, but it depends upon the how you guys are getting these points. See here, I will show you the code explanation, not an issue. But check out, I'm passing third column here. The column transform, already we have seen this kind of structure in the label encoding concept. Okay, and column transformer is my this class, and transform is my method. Encoding is my concept that I'm applying. One hot encoding we are applying, that's why that is in your method. And one hot encoding you are applying on which column? One hot encoding you are applying on which column? State column, no? Means that is in third column. So you guys are thinking about that is in third column, yes or no? Yes, check out. This is my 0, 1, 2, and this is third. So you are telling to your column transformer, there is, we are having third column, you can take it, convert it into the binary. So that what he has done, he has taken that third one, comma, reminder pass through. If you should have to work on only third one, third column, whatever remaining part will be there, you should pass through the, means you can take also that work on the third column and go with the other data as well. So the third column we are taking here, and ct dot fit transform data is an x, means fit transform means nothing but you have already seen that that fit transform model prediction purpose, you have used the regressor dot fit previously, you saw that one. So fit method is used for why? To get the data from the means client and pass through into where? Get the data from the client and pass through data into the one hot encoder, or you can say column transformer. So he is taking the x data and pass through into the ct. Who is a ct? Who is a ct? Column transformer. And what is the work of ct? Converting. What is the work of ct? Converting the, encoding the data on which column? Third column. What is the name of third column? State. How many categories we are having? 3. How many columns we will create? 3 columns we will create. So check out first one, second one, and third one. So now the question will rise, how can we identify that first column is belongs to this category, second column is belongs to this category? That is the toughest thing. That is the drawback of this one. You got the point now, guys? Just a minute. Just first and second are converting automatically. No, you are passing third column only, and third one has in three categories, and three categories are converted. So binary values will be based on what? How did he choose the default value? That's the question, Rahul. That's the question. Means which part I have to give 1 second. Actually, how many categories we have? Three categories. So the way he choose, suppose first one, suppose New York he choose. That's the question you ask maybe, right? Even I'm getting the confusion about which one he is taking. But definitely I will check that one and I will give the answer to you. Yeah, means on the basis of on means suppose on the basis of your number of counts, on the basis of number of counts, or randomly he is picking out that one. But definitely I think maybe he's taking on the basis of count. Means if suppose New York is in highest number of count, then definitely he will go with it. Possibilities that you said alphabetically, possibilities, but I will not give you 100% sure of that he's going with that exact concept, because I don't want to give wrong advice. But okay, three categories, are converting into the 0 1 0 0 0 1 or 1 0 0. Sir, you are thinking wrong way actually. You know what happened? Just see, I'm explaining this one, and we'll just, stop this session here, because we are taking today a huge amount of data. So I will explain this one and we'll go off. Tomorrow I will start from here as well, so we'll cover up this one. Okay. Now see, the first point, 1,65,000, whatever the first value, just see the first value, 1,65,000, 1,36,000, and 4,71,000. That belongs to what? New York. And see here, New York. 1,65,000, 1,36,000, 4,71,000. That belongs to New York. So this column is belongs to New York. Why? Because that is considerable as a one first one. So others are 0 0. What is the second value that we have? California. So California, here we have the 1,62. This one, check out 1,51, 4,43. That belongs to what? California. So California column is belongs to this California. So whenever your observations are belongs to that particular category, there is an 1. And suppose your observation is not belongs to that category, there is an 0. You got the point now? I'm asking to you all guys, because that is the major thing. Question, we converted in one Jupyter column transformer values will be same with the same dataset column conversion on the different Jupyter tab. Means see, the question is that, means if suppose if you converted, if you have done the conversion, you know what you have to do? You have to save that data into this some different CSV files, so that next time you will not get chance to convert once again. Is it correct? No? Because if you go for the always conversion, then that is kind of it's not good work. So once you convert your data, and then you can go for the storing into the CSV, and you know that how to save this data into the CSV. That is an 2 CSV concept method we have. So you can go for that as well. Next time when you come, no, that time this will be comes same, means you can put that data, original data. Yeah, you can directly go for the prediction instead of converting. Yeah. So guys, I think hope you learned today so much, right? Even I'm happy with your presence, right? Thank you so much for giving such a good time. Yeah, thank you so much, guys. You are enjoying. That's the great thing, no? If you are enjoying, so many peoples they get stuck in between that. So you are enjoying. That's great. Thank you so much for this one. Thank you so much. So tomorrow, actually, when coming sessions will come, no, that definitely you will get more enjoy. So till the end of the course, you will enjoy so many things. Okay, guys, I think let's go for the tomorrow session. And till then, let's actually take care of yourself. And thank you so much. See you. Bye bye.